Natural resources such as oil can only last us so long. In the past, fluctuations in gas prices have led to mass hysteria and long lines. As humans quickly deplete the oil deposits left here on Earth, there has been a rush to find alternative sources of fuel. At the forefront of that rush for fuel alternative fuel stands cellulosic biofuel.
Cellulose is the main component in plant cell walls. This complex carbohydrate is made up of chains of glucose, which essentially allows plants to store energy for long term use. However, the nature of the links holding the glucose together is different in cellulose, and there are fewer identified organisms with enzymes that are capable of breaking down cellulose. Enzymes work in a lock and key system. Each enzyme matches a particular molecule. Without the right enzyme, you cannot build or degrade a molecule biologically. However, with the correct enzyme, cellulose contains huge potential as an alternative fuel source.
In the past, people have used cooking oil from restaurants in order to fuel their cars as a way to save money. This, however, failed to gain widespread popularity as a widespread fuel source. However, as the rush to find an alternative source of fuel continues, more and more research has been done attempting to use organic compounds as a sustainable source of energy.
Cellulosic ethanol is a type of biofuel produced from lignocellulose, a structural material that comprises much of the massive plants. Lignocellulose is composed mainly of cellulose, hemicellulose, and lignin. This can usually be obtained from simple compounds such as wood, grass, etc., which are found all around. The complex sugars in these organic biomasses are broken down in a process similar to that of making alcohol. They are fermented using various enzymes, and eventually a byproduct of ethanol is produced. Ethanol is then usually mixed into gasoline, which allows it to burn cleaner.
Algae-based biofuels are another alternative energy which is currently being developed. Algae fuels release CO2 when burnt, but unlike fossil fuels, algae fuel and other biofuels only release CO2 recently removed from the atmosphere via photosynthesis as the algae or plants grow. The soils in the algae can be released by breaking down the cell structure via the use of solvents or sound waves. Algae also have the potential to produce up to 60% more oil than land-based plants. This may all sound very good. However, this would beg the question of why we haven't switched over yet, and the answer to that is a number of complications. For one, the switch from fossil fuels to cellulose does not benefit oil companies. These companies have been a huge part of the way energy is produced and consumed, and such make the switch to biofuels more difficult. In addition, producing these new forms of energy often takes more time and research than with the more simple extraction of fossil fuels. People want a simple source of energy that they can get for cheap. So far, the incentive to make these biofuels has been depleting resources and protection of the environment. These threats do not seem very immediate, which has stagnated the production of biofuels.
Production of large amounts of biofuel also requires monoproduction, or the production of a single crop. This, while attractive to farmers, also depletes soil, making continued production of a single crop more difficult. There is only so much land, and dedicating land that we have now to balance with the food we eat is difficult. With that, huge amounts of water are also needed, bringing another layer of complexity to the production of fuels. In order to expedite the production of biofuels, the government can provide subsidies for research of the production and creation of biofuels in order to make them more widely available and affordable for more people. People will act to make themselves better off and won't buy a source of fuel if it hurts them in their pockets. This new source of energy is renewable and more secure than fossil fuels. If we don't want to trigger our future kids, the switch is necessary.
In regards to the average consumer, biofuel provides significant improvement over our current sources of fuel in terms of efficiency. Cellulosic ethanol reduces greenhouse gas emissions by 85% to 94% compared to petroleum-based fuels. Cellulosic biofuels reduce competition for agricultural land. All biofuels are made of some form of plant material. Cellulosic fuel crops can grow on lands that aren't the best suitable for agriculture. In fact, if the crop grows on land that has already been cleared, the cellulosic crops do not release carbon into the atmosphere. Biofuel is degradable. As ethanol is made from highly organic materials, it's highly biodegradable, making spills far less of an issue than with petroleum-based fuels.
However, this fuel source can have its cons. Ethanol absorbs water, which can contaminate it as a fuel source and make it more difficult to ship through pipeline. Ethanol absorbs water and is corrosive, which makes it more difficult to ship through existing pipelines from the Midwest, where most production occurs. Remedies include shipping or building dedicated ethanol pipelines. However, the most likely scenario seems to involve rail or road transportation. The best scenario would be local ethanol plants, with the easiest way to accomplish this through continued development of cellulosic ethanol, where feedstocks are abundant everywhere as opposed to corn or sugar. In regards to production, cellulosic biofuel not the easiest to produce. Producing biofuel becomes harder when starting with more complex carbohydrates from plant materials. Despite the difficulty of production, cellulose makes it up nearly half of all plant biomass, meaning cellulosic ethanol is one of our best potential sources for biofuel in the future.